Hi everyone, happy day after Cinco de Mayo, which would be May 6th, which is today. Today we're going to be talking about one of my favorite topics in mathematics because of its wonderful properties, and for me, some of its simplicity, and also the applications that we'll be able to see with this. And that is, we're going to be talking about this idea right here, about geometric sequences. So things to pick up during this video that you'll hear me talking about. First, we're going to talk about a geometric sequence. During that discussion, you'll hear the word common ratio. You'll also hear an initial term, and another word for initial is first term. So by the time we get done with this video, hopefully you will know what all three of those things mean right there. Okay, so here's a geometric sequence, and I'll show you what I mean by geometric sequence. We've got this sequence, and what I want us to do is to find the initial term and then the common ratio. So when we look at these numbers, if we look, our initial value is going to be 3, or our initial term, I should say. So the initial term is always going to be your first term, whatever it is in the sequence, whatever the first number is in the sequence. In this case, that number is 3. So our initial term there is 3. Then what we're going to try and do is we're going to try and find out what pattern, if any, does there exist. I shouldn't use red because it's already in red. That allows us to go from one number in the sequence to the next. So you might be asking yourself, okay, well, how would I go from 3 to 6? What mathematical operation would allow me to go from 3 to 6? And then from 6 to 12, 12 to 24, and 24 to 48. So what I'd like you to do, what I'm hoping you'll do, is you'll pause this video for a moment and try and find out if you can see a way to go from 3 to 6 to 12 to 24 to 48 and so on, using a mathematical operation. And what I mean by a mathematical operation is adding, subtracting, multiplying, dividing. So pause it for a minute, and then we'll be right back. And we're back. Hopefully you paused and you went through. So when you looked at this, I'm hoping you were able to see that, well, if I were to times by 2, 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, and 24 times 2, that is a times symbol there, sorry about that, is 48. So when we see that pattern, where to go from one term to the next, we simply just multiply by the same number every single time, doesn't matter what our number is, but we multiply by the same number every time. That is what's called a geometric sequence, if it has that property. So for us, 3 times 2 is 6, 6 times 2 is 12, and so forth. It's the same number over and over that we multiply by. It's this times 2, times 2, times 2, times 2 that we have going on here. And that's what defines a geometric sequence. Now that number that we're multiplying by is what we call the common ratio. So the common ratio is the number that you multiply by each time in your sequence. And that's what denotes a geometric sequence. And a common ratio is going to be denoted by a lowercase r. Oops, my iPad's giving me some problems here. Here we go. So lowercase r for common ratio, instead of writing common ratio every time, that's a lot of work. So we'll say r equals, for us in this case, 2. Our common ratio is the number 2. Okay, so there we have it. A geometric sequence is a sequence where you multiply by the same number over and over. In our case, we multiplied by these 2's over and over. The initial or first term was 3 because that's what we started with. And the common ratio, lowercase r, so every time we see lowercase r, it would be the number 2. It was equal to 2 because we were multiplying by 2 each time in our sequence. Hope that helps. I hope now that when you hear the words geometric sequence, common ratio, and initial or first term, that you have an idea as to what I'm talking about.